All right, we are going to continue. We're going to do two questions now. We're going to do question number 11 and question number 12. Question number 11, let me get the pen ready. It says, in a survey, 500 children ages 6 to 11 in an elementary school were asked whether they read books for fun for every day. The responses, yes or no, broken down by gender, are summarized in the table. So, for example, um, these are boys who said they like to read for fun. These are girls that like to read for fun. These are boys that do not read, don't like to read for fun. And these are the girls. So the first question is, what proportion of children in the survey are boys? So the question is, what proportion? So to be able to do that, we need to add this column. And if we add 48 plus 182, you're going to get to 30. Maybe we can add all of them since we're doing this. This will be 270. And if we add horizontally here, there will be 124. And the next one will be 376. And it has to match 500 and 500. So to answer the first question, it's what proportion of children are boys? Boys is 230. These are boys divided by the entire list of boys and girls. That will give you an approximately 46%, right? If you multiply times 100, your answer of the division, it will give you that. B, what proportion of boys in the survey read books for fun every day? Just the boys for fun. Well, just the boys for fun is 48. And they want to know only boys. What proportion of boys? So we're only talking about boys. So we're only going to look at this column. What proportion of boys is 48 out of the 230 boys. If you do that, it's going to give you a 20.9%. Okay. C. What proportion of girls in this survey read books for fun every day? So now we're talking about girls, and they like to read for fun. That's 76 divided by only the girls, because that's what they want, girls, right? So if you did that, it will give you approximately 28.1%. I should use the approximation symbol because it's not equality. So that's a correction there. A, B, C, D. All right. Do the result of the survey suggest that gender of a child has an effect on reading books for fun? Well, let's see what is the percentage of boys who like to read for fun, right? The percentage was 20.9%. And let's compare it with girls who like to read for fun. And we just got that number here. We're comparing 28.1. So it looks like girls are more likely to read for fun, are more likely to read for fun. So the answer, yes. Actually, whether the gender, whether it's a boy or girl, has something to do with that because girls have a higher percentage. Okay, and the last question, I'm going to do it over here on the top. And it says, suppose a child is selected at random from this survey. Are events a child reads a book for fun every day and a child is a boy independent? Now, if you remember, we had a formula to prove independency, and if we haven't, this is the formula for independency. It's P times P of A times P of B. This is the formula if you ever want to prove independency. A is the event. What is it there? A child reads for fun. That's the first thing. So this is fun. B, we're going to say, it says that the child reads for fun is the first, a child, so it's not a boy, girl, it's just a child, and a child is a boy. So we're going to replace the values here to prove independency. So the probability of A and B, and B, what is the probability A and B? Well, A is fun and B is boy. Read for fun and a boy. So that would be 48 over 500. 48 over 500. This time we say 500 and not 230 because they're saying a child. So it could be any of them. So we are not comparing to only boys, but we are comparing to the whole group. So now the other one is P of A times P of B. Now P of A is the probability that people read for fun. So fun, if you look at the column, the row of fun is 124 over 500 times, the next one is just boys. Now boys, the total of boys 230 over 500. We are using the denominator of 500 because we're talking about everyone. Now if you look at this, and now let's compare this with that to see if that is correct. So this one gave me 48 over 500, and this one gave me 124 over 500 times 230 over 500. If you compare this, clearly this is not going, you can use your calculator, but clearly it's not going to be the same. All right, let's move on to the next question. Question number 12, I'm sorry. Let's make this a little bit bigger. A bin contains a container contains 3 red balls and 4 green. So we're going to say green, 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 and green. That's easy than writing the whole word. 2 balls are chosen at random, so we're going to choose 2. That's 1 and 2. And let the without replacement, let the random variable x be the number of greens. X is equal to the number of green balls. Okay. And the first question is, explain why x is not a binomial. It's not a binomial random variable. Well, each time you choose a ball, the probability will change because you're doing it without any replacement. So you're doing it without replacement. So the probabilities are not going to be the same. That's one reason. Not the same probabilities every time you do the event. B. Use a tree diagram or sample space to construct a probability distribution table. So in the table, we are going to look at the choices that we have. We're going to choose 2 balls. Okay, so 1 and 2. And you can have, for example, a green and a green. Yeah, that's a possibility. You can also have a green and a red. You can have a red and a green. And what else you can have? You can have red, right? Red. So these are X is the number of greens. Here we got 2 greens. Here you have 1 green, 0 greens. Now we're going to get the probability of getting that. So to find that probability, we're going to take a look at each case here. Since we're selecting 2 balls from every of one of those probabilities there. So let's take a look at the first one. Green, green. Well, what is the probability of green, green? Well, there are 4 greens, 4 divided by the total, 7. And the next time you pick one, you want another green. This is the first time, and this is the second time. You want another green. Now, you don't have 4 greens anymore because you're not replacing them. You only have 3 greens out of the 6 that you have now. So you multiply that, you're going to get 12 over 42. I believe that they simplified this by dividing both numbers by 6, right? So simplify that, and you're going to get 2. Probability is 2 over 7. Okay, let's do the next one. What is the probability of the first one is green. Green, again, we'll start all over again because this is another situation. Green is 4 over 7. And the next one is a red. Red, you still have the 3, so that will be 3 over 6 this time because you don't have that. So that will be 12 over 42, which is the same as we had before. It simplifies to 2 over 7. You can guess that red and green probably going to be the same thing. Red is 3 reds out of the 7, but the second time you pick a ball, it's going to be a green. Green, you still have the 4 greens, but you don't have 7 because you did it without replacement. You only have 6, and that will give you 12 over 42, which also remains the same as before. The last one you want red, red. So the first has to be a red. You got 3 out of 7. You see 1, 2, 3. And the next one, since you already picked 1 red, you only have 2 red left. And you don't have 7 balls, you only have 6 balls. So that will be 3 times 2 is 6. 6 over 42. You can simplify that by dividing top and bottom by 6, right? And you're going to left 1 over 7. If you add all of this, just to double check, it should be equal to, if you add all that, it should be equal to 1. So this is your table. This is the probability distribution table that they were asking you. And it's basically 2 columns, this one and that one. The possibility of greens and the probability of each event. And I just did this to show you how I came up with the probabilities. All right, that concludes our video because the bell already rang. So we are going to stop that.